Hi, my name is Elena, and in this video we'll talk very briefly about GraalVM Enterprise, what it is and how it can run your applications faster. So GraalVM Enterprise is a high-performance runtime that can provide significant improvements in application performance and efficiency. It is based on Oracle Java SE and can run applications written in Java, other JVM-based languages, and also languages like JavaScript, Python, Ruby, R, and LVM-based languages. Now, if we talk about Java applications specifically, GraalVM can run them in two modes. The first mode here is GraalVM Jet mode, in which GraalVM can just act as your JDK distribution with easy migration and high performance. These performance improvements come from new heavy optimizing GraalVM compiler. Some of the optimizations that GraalVM compiler performs are, for example, best application, optimization-driven inlining, and advanced speculation. What is interesting, GraalVM compiler can also significantly reduce garbage collection overhead thanks to partial escape analysis. Such improvement, for example, was confirmed by Oracle Cloud Infrastructure running production services on GraalVM. Now, another way to run your Java applications on GraalVM is GraalVM native image mode. In this mode, GraalVM will compile your Java applications to native executables that don't require JVM to run, start in milliseconds, and need very little memory. This makes them perfect for cloud deployments, where you want to start fast, scale easily, and use your cloud resources wisely. And another mode here is GraalVM Polyglot mode, in which GraalVM can execute all those different languages and also work in context of different platforms, but this will be a topic for a different video. Now, let's see some GraalVM action in practice. For that, I want to show you a few demos, and the first demo is running a sample workload with and without GraalVM compiler. So without GraalVM compiler, we will be just running it with a default C2 compiler. Let's run it without GraalVM first, and for that, I will disable GraalVM compiler using this flag. So let's run the benchmark, and second time we'll run it without GraalVM and compare the numbers. Okay, our numbers are up, and the final number is 284 nanoseconds per operation. Maybe it is fast, maybe it's not. Let's compare it with GraalVM compiler and see the exact numbers. So for that, I will just run it with GraalVM. Okay, so this iteration is also finished, and now we see that this time our score is 13.6. I just want to point out that here we are measuring nanoseconds per operation, meaning lower numbers are better. And if you recall, here we had 284, meaning the second time speed up was about 20x. I just want to add here that, of course, everyone's workload is different and every workload will see different performance improvements. But the bottom line here is that performance improvements like this are possible with GraalVM. And to find out what improvements can your specific workloads experience, the best way would be to run some sample workload on GraalVM and measure performance yourself. So this was for jet mode, and the performance improvements when running in jet mode. And the second demo I want to show you is this micronode application. So here we will run it also 2 times, just we will be comparing the jet mode in first time and GraalVM native image mode in the second time. So let's run it in the jet mode first. Okay, so we see that our application started and it took it about 2.2 seconds to start. And let's see what it does. So here's my application and I see that upon request, it returns me a random name from the list. So that's its functionality. Let's kill it here and double check here because I want to use it once again. And the second time, I already have it compiled here as GraalVM native image. So right now I can just run it as a native application. Okay, we see that it started. Let's just quickly check what it is doing. And as we check, we see that it has the same functionality. It's the same application, right? So when we compare, once again, numbers here, we see that this time it was well, maybe not 10x faster, but about 8, 9x faster. And that is a difference between GraalVM native image mode and the JIT mode of executing Java applications. So these numbers were measuring startup time. But what about other metrics that we could care of? For example, CPU usage and memory usage. So if we look at them, and here we were measuring them for the exact same micro application. So if you look here, we see that in JIT mode, our CPU, those red spikes, is quite busy up until about 2 seconds. And also the memory usage is relatively high because when we look at the native image mode, we see that CPU is only busy when those actual requests arrive and need to be served, and also memory usage is quite low. So it was this application, but in fact, GraalVM native image is working really well with many Java microservice frameworks. You can use Micronode, as we were showing here. You can use Helidon. You can use Quarkus. And another application that I want to show you is our ongoing collaboration with the Spring Boot team. So there are those sample applications, and you can get them and build them and compile them as native images. And when you do so, I want to show you the speed up that you can get for your Spring Boot application. So let me run it, and I should have it compiled already. Yeah, I have it here, so let's run it. Okay, so it started, and we see that it starts really fast. And that is the difference that GraalVM native image can bring for your Java application. So that is all I wanted to show you today. So if you want to learn more about GraalVM, please go to oracle.com GraalVM. And if you're ready to try and run applications on GraalVM, you can download it from this URL. And also it is available on Oracle Cloud, so you can use GraalVM Enterprise there. That's all for this video. Thank you.